if you took a 100-watt power supply in the UK, a baseline power supply that just passes the standards, use that as the reference, versus a higher efficiency PSU that gives data back via IoT so we know accurate usage profile, we can show that over 100,000 installed base, we've got over 370 tons of CO2 emitted savings, which is nearly 15,000 trees or 26 hectares of the Amazon that are being saved, as in not being utilized.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Haydock. With rising energy costs and a greater push towards sustainability, industries increasingly turn to IoT solutions to optimize energy consumption and reduce waste. IoT is not only about smart devices, but about gathering data to make smarter decisions that drive both efficiency and sustainability. And to help us unlock this topic, I'm thrilled to welcome Andy Richardson, an expert in this field and a key figure at Salom Europe. Andy has worked extensively on how companies can leverage IoT and data to create more energy-efficient operations. And today he's here to share some of those insights with us. Welcome to the show, Andy. I'm thrilled to have you.
Hi, Ruth. It's great to be here as well.
Before we are diving into IoT and power saving specifics, can you tell our listeners about your background and your role at Salom Europe?
Sure. I'm VP of Business Development at Salom. Salom's been in existence for nearly 50 years. We make power supplies for a range of applications, primarily consumer applications. And to date, we've manufactured nearly 3 billion power supplies, which are in homes across the world. So I think we've got a pretty good idea of power architectures, power supplies, and broader implications on what this means in a system.
So saving trees with power supplies sounds controversial. Can you elaborate on this?
Yeah, absolutely. So, of course, many of the environmental issues are very apparent in this day and age. It's an extension that a lot of people don't necessarily think about, but power is ubiquitous. It's everywhere. It's driving everything. And it is one of the key factors in CO2 emissions. You know, it's very easy to think of it at the sort of national infrastructure level that, hey, if you've got a coal-fired power station, it's not as good as a wind turbine. But what does that really mean at the consumer level? Because all of this cascades through. And that's what we're talking about. It's how you make more informed decisions on your power supply choices that reduce those CO2 emissions. And a CO2 emission is ultimately something that a tree has to sequestrate. So by reducing your CO2 emissions, you are saving trees.
That's good news. And why is IoT such a game changer when optimizing power usage?
Well, the key factor here is, do you know what power you're actually using? So I guess the simple analogy would be, at the consumer level, in the modern smart home, you have an in-home display, so you can see what your power usage is. But for businesses cutting across multiple consumers, maybe multiple regions, which have different power infrastructures, of course, it's necessary to really understand what your power usage is across your infrastructure to be able to accurately report your CO2 emissions. And this is now a mandatory requirement on these businesses that are aiming to be net zero by 2030. Of course, they have to know what the emissions are to be able to do something about it, either through design of better equipment or utilizing carbon offsetting schemes. But it has to be recognized that with changes in EU legislation, you're no longer allowed to use the carbon offsetting schemes as a form of greenwashing to say your products are carbon neutral. You know, you have to, in many ways, educate the consumer and say, okay, we are emitting this much CO2, but we're offsetting it through this means. So carbon offsetting schemes are valuable and important, but what's more important is understanding what your real power usage is and making design decisions that then minimize that. That's where IoT can come in.
And also with offsetting, you're actually not really saving energy, are you?
Well, and that's really the point why the misrepresentation to the consumer is important, because many consumers, they want to make informed buying decisions. And, it's not correct to display two products as carbon neutral, for instance, when one is neutral through offsetting and another by design. The consumer would rather solve this at the root cause, not by an alternative scheme. And that's really what the intent of changes to the legislation is about. Is don't try and hoodwink the consumer. Let's try and solve this at the root cause. But the only way you can do that is through data and analyzing what your usage really is to determine what you can do about it.
So data obviously plays a really important role in this. What kind of data do the IoT systems have to collect to actually create actionable insights for saving power?
Yeah, so ultimately, and try and look at a simplistic level, you have a power supply that's consuming power off the grid, off the mains, and it is inefficient, or it has an inefficiency. So, for instance, if it's a 10-watt power supply that's 90% efficient, you've got 9 watts coming out and you're wasting 1 watt. So really, what we're really most focused on is understanding what those inefficiencies are, because those are the things that are contributing to excess CO2 that you can do something about. And that's what the data is giving us. It's a better understanding of the inefficiencies. Now, there is an argument that says, well, okay, it's certified. We know in the test documentation what the inefficiencies are. Well, that's true, but what you don't know is the user profile. Different users would use that power supply in different ways. One might have it on 24/7 at full load. One might have it at 25% load for half of the day. Somebody else might have it in standby for the whole day. So only when you understand that total usage profile, bearing in mind the efficiency changes across that usage profile, then you can see what your real CO2 wastage is and then make the decisions to resolve that.
And can you share some examples or use cases?
Yeah, absolutely. I mean, as I say, it depends on what the application is, but you can have an example from something like a set-top box that could be on 24/7 to another infrastructure of, say, street lamp controllers, which have a very different type of profile, a CCTV network. There's different applications that would all have different usage profiles. What's important is that we can model all of these, in essence, take in the country of operation, each national government creates figures on the conversion of kilowatts to kg CO2 emitted based on their power infrastructure. So, for instance, if your infrastructure was coal, then it would be a much higher figure than if it was wind or wave. So, taking those base figures, you can model an installed base of, well, we supply customers up to 1 million units a year. Industrial applications are lower. So if you said over 100,000 units of whatever this application is in, let's say, Germany, so we know what the baseline kg CO2 figures are, then we can model that usage profile based on IoT data feedback, convert that into what that really means in the number of equivalent trees or kg CO2 for scope 3 reporting, which it's mandated the customers have to do, and even convert that to hectares of the Amazon if you want. So we have an example that if you took a 100-watt power supply in the UK, a baseline power supply that just passes the standards, use that as the reference, versus a higher efficiency PSU that gives data back via IoT so we know accurate usage profile. And we can show that over 100,000 installed base, we've got over 370 tons of CO2 emitted savings, which is nearly 15,000 trees or 26 hectares of the Amazon that are being saved, as in not being utilized because the CO2 is not being emitted in the first place because of this higher efficiency PSU, that you know how it's accurately being used.
That's incredible.
Yeah, the figures are genuinely astonishing. But as I say, we can model these, but it all comes down to having the data to model these on. And this is, again, so important for Scope 3 emissions. So businesses now have to report the CO2 emissions, and it's covered by scopes. So, Scope 1's, everybody understands the changing fleet vehicles to EV, and Scope 2, changing your utility provider to green energy. But Scope 3 is really to do with the supply chain and your products and the products that you're supplying. So take that application that I just referenced, say 100,000 units of 100 watt PSU, you may have to assume a worst case that everybody's using that 24/7 at full load because you don't know otherwise. You can't just guess at the data. The whole point of the emissions reporting is this is factual based data. So what do you do? So we're saying that you can IoT-enable the power supply to back all that data, and it may not be necessary that every power supply deployed has to be enabled. Maybe 1 in 10 gives you a proxy for the installed base that's accurate enough. Depends on the application, of course, and the variability of the user profile. But we're saying with data, you can properly model these. And if you report on your actual usage, not what you think could be used as a worst case, there's an instantaneous saving without really changing anything. It's because you've got data to make informed decisions. So this is all about data-driven design and reporting so that you can accurately report the figures rather than guess.
And I imagine that also opens up a whole new world of business models for companies that also they can leverage new opportunities through this, right?
Very much so. And this IoT-enabled data enables informed business decisions on both the design, but as you say, the business models as well. You could find that if it makes sense for you as a business to design your product to be peak efficient at half load, then offer the consumer incentives that enables them to use it more at that level. So there's all sorts of ways that you can drive consumer behavior and new business models that follow that.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by Avnet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com. Can you think of some other challenges companies might face when integrating IoT for power management?
Yeah, well, the immediate one that we would regularly face is the cost. So, a business might go, well, this is going to cost us a lot extra, and why do we want to do it? Well, actually, if you model those cost savings at the system level, what they really mean to the business instead of buying CO2 offsetting tokens versus the increased cost of the power supply, then, the savings are easily washed through. So it's changing the business discussion to really about the cost savings at the business level, not the product level, because this is a bigger system discussion than the exact product. But even then, if you accept that cost of the PSU would increase because of these extra features, in many instances, that could possibly be passed on to the consumer because the consumer pull is there for better products. But therefore, they have to be marketed and communicated differently, which is invariably what the changes in the EU legislation is about. It's educate the consumers, don't try and hoodwink them.
Mm-hmm. And I'm trying to think of examples. Are there any industries or types of businesses that would benefit most from leveraging a business model that leverages data to make more energy efficient power supplies?
Yeah, it's basically any business that has an installed infrastructure that they need to monitor the power usage of based on CO2 emissions. So, as I said,
basically everybody.
Yeah. Well, I mean, it could be the instance that, a business is selling a product that the consumer buys and that's it. It's done. It's all the consumer's problem. In that instance, the consumer may wish to pay a premium for a better product simply because they want to do the morally correct thing. Alternatively, there are businesses with deployed networks out there that go, they don't charge for the products. It's all covered under a service contract. Sign up for a service with us. Mm-hmm. We provide the equipment to you. Now, as I say, it could be varied what the applications are, but in those cases, the business providing the equipment is responsible for the CO2 emissions in the field as they're deployed across the whole installed base. And as I say, this could be across different energy suppliers, across different countries, across different types of consumer. So how do you gather that data? So this is what we're enabling for anybody with an infrastructure out there. There's a benefit to monitoring the actual power usage in real time. Well, that's what we're communicating and targeting.
That's a real interesting shift in strategy, basically. How does Salom Europe approach this differently than your competitors? What sets your strategies apart?
Well, obviously we have our competition like everybody else. The analogy I give is you don't win a race by looking over your shoulder. We intend at the front of the pack and do the best we can do and let the others worry about following us. So for us, we just know that with all of the market shifts to being more environmentally aware and some of the corporate challenges with net zero by 2030, we understand this, we can model this, and we can help guide our customers on the best path forwards. But what that path is will vary based on the customer's application and needs. That's fine. We will modify that accordingly. If a competition wants to try and have the same conversation, then, good luck. The more people that are having this discussion, the better, in our opinion.
Yeah, absolutely true. What do you envision for the next 5 years? How is this market going to evolve, or what future trends do you see in energy efficiency?
Crystal ball time. It's a difficult question. Obviously, what we know is the one thing we know for certainty, we're not going backwards. Energy efficiency, energy conservation, greener energy sources are only going to get more and more important as most countries fall behind the trend to net zero by 2030. Because let's be under no illusion here, that's a massive challenge. And, have absolutely no doubt that some countries won't be able to deliver on that. That's a huge infrastructural issue. So there has to be smart supplied. We all talk about the smart grid. Well, this is the smart network in action. But we can't just devolve responsibility to the national governments. We all have a part to play, whether it's informed consumer buying choices to buy a better product, down to businesses that are enabling backhauling data to make informed business decisions. This is everybody's stake in the game. But my best guess is we have a massive challenge now, and that challenge is only going to get bigger as we move towards 2030.
Just when you mentioned the governments, what role do regulations play in this, or will play in the future?
It's a really good one. Unfortunately, regulations are usually slow to change. So the most important regulation here is the eco-design legislation that sets the minimum efficiency of power supplies. But as I said, using our modeling, we can take a baseline of the most inefficient power supply allowed by the standards versus what we can deliver with a more efficient solution. and show there's a massive saving. So the standards could evolve dramatically. Unfortunately, they are often slow to move. So we can't influence those standards, but I think the standards bodies, of course, they look at what's going on in the industry. They slowly shift the bar up and up. It's not going down. That's a good thing. But as I say, the motivation to do more than required is there, considering the consumer pull and the business needs for better products.
And would you say that also the discussion will then also evolve around the material needed for creating power supplies? Like I'm thinking lithium, or where you then have either very dangerous material or different supply chains, because most of those
absolutely.
come from either, I don't know, Southern America or Africa, and then that opens a whole nother bucket of problems, doesn't it?
Yes and no. A lot of these supply chain issues are already covered by different legislation. So, we have to do all conflict minerals analysis, etc. So it doesn't really change that. But you're absolutely correct. This does change how we source materials, because when I mentioned about the carbon footprint reporting, when we provide a power supply to our customers, we have to do full life cycle reporting. Now, for us, that means we can report on the CO2 emissions for sourcing the materials that go into the product and the manufacture of the product. But that's the limit of our reporting, because we can't report on the usage, because that's controlled by the business that we're supplying the power supplies to, or indeed the end customer. So our limits of our reporting are in material sourcing and in manufacturing. Now, as a factory, there's all sorts of things we can do with manufacturing, and we do that, whether it's, green energy sources or more efficient injection molding, whatever that may be. But your question is a very good one, because this applies to the material sourcing. So yes, we absolutely have to look at the carbon footprint credentials of the product we're supporting, but more importantly, the transportation of those to our factories. So these are all wrapped up in our life cycle CO2 reporting to our customers, to make sure doing what we can to minimize the footprint of the delivered products prior to use. But that's already part of the so-called ISO 1400 series of standards. And in fact, it's the ISO 14067 that's the particular standard on the CO2 emissions at that product level.
Interesting. And do you have some advice for companies who are now excited about exploring IoT solutions for their power management? What would be some first steps for them?
First step, give us a call. We can come in and talk about the models, the modeling, their applications, and how it may apply to them. There may be instances for their use case or products that they have deployed already. Maybe the gains might be minor, but the point is it's fact data based. It's not subjective and guesswork. So I'd say the first step would be give us a call. We'll see what we can do to help. In my experience, we can always help.
What is some low-hanging fruit that they could target?
That's a difficult question. I would suggest that the problem in terms of CO2 emissions scales with the higher power products. So as you increase the power of the power supply, you have a bigger problem, also because that inefficiency scales. So, for instance, I mentioned the 1 watt inefficiency of a 10 watt power supply. Well, if it's a 100 watt power supply, maybe that's 10 watts. So it's a combination of the size of the power supply and the numbers of power supplies deployed in the field. So I'd say if you have a lot of higher power products in the field that you don't know how they're being used, you should be. So you should be concerned about this. So I'd say at least start modeling that, and we can help modeling that. And then you can really see if you have a problem. If you've only got 20 or 30 1 watt power supplies in the field, the problem is relatively minor, and that's washed away on, say, transportation issues, which might be a bigger issue for you. So I'd say, first of all, start looking at the volumes of products you've got deployed in the field and the sort of size of the power. And you can then quickly determine this could be significant for you or not.
That's some great advice. Thank you.
It's all down to everybody taking an interest in, their actual behaviors and usage, whether that's the willingness to purchase a better product at the consumer level or even at the business level, an interest not just to do the basics to pass the standards, but take that next step and really look at what you're doing and how you can help make the gains that we all need to make to reach these zero goals, because it's not going to happen on its own.
Those were some great last words. Thank you so much for being on the show, Andy, and sharing your insights. It has been really interesting, and it's really amazing that you can actually save trees by using power.
Indeed. Well, you're more than welcome, and thanks for the opportunity to have a chat.
Thank you.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.